burn like a pro.
So get this. What if I told you that the same thing that powers a rocket into space also gives the astronauts drinking water? It sounds like science fiction, right? Well, it's real. And that same tech could, one day, be powering our cars and our homes. We're going to dive into the absolutely incredible science of hydrogen fuel cells.
All right, so here's our game plan. We're going to kick things off with the really cool part, rockets. Then we're going to zoom way in and look at the actual science happening inside a fuel cell. After that, we'll tackle the big questions, like where do we even get the hydrogen? What's stopping us from using it everywhere? And the big one, could this really be the tech that powers our future?
Okay, first up, hydrogen as the ultimate rocket fuel. We're talking about the simplest, most abundant element in the entire universe. And it just so happens to be pretty much perfect for blasting things off our planet. So, let's really think about that question I threw at you at the beginning. How is it even possible? How can one single system give you the raw, massive power you need for a rocket launch, and at the same time create something as basic and vital as drinking water for the crew? It seems like two totally different worlds.
Well, the answer, of course, is hydrogen fuel. And for space travel, it's a total game changer for three big reasons. First, it is ridiculously lightweight, and when you're trying to escape gravity, every single gram matters. Second, it's a super clean fuel. It doesn't create any nasty pollution. And third, and this is just the most brilliant part, the only thing left over from the whole reaction is pure clean water. Literally, astronaut drinking water.
Okay, so we get why it's great for rockets. But now let's get into the how. It's time to, pop the hood and see what's actually going on inside the fuel cell. We're going to look at the clever chemistry that turns two simple gases into electricity.
So the easiest way to think about a fuel cell is like a battery that just never dies, as long as you keep giving it fuel. It takes hydrogen and combines it with oxygen right from the air. But here's the key, and this is the most important thing to remember. It does it without burning anything. There's no flame, no explosion, just a quiet, controlled chemical reaction that gives you two things: electricity and water. That's it.
Okay, to get how these things are built, we're going to use a little analogy here. Now, this diagram isn't showing a hydrogen fuel cell exactly, but it's perfect for showing the three basic parts that every fuel cell has. You've got a positive side, that's the anode, a negative side, the cathode, and then this special stuff in the middle called an electrolyte, which is kind of like a bouncer at a club. It controls who gets through.
So how does it all work? Well, it's actually a pretty elegant four-step process. First, hydrogen gas comes in on one side, the anode. Step 2, it gets split into its basic parts, protons and electrons. Now, for step 3, those electrons can't go through the middle, so they have to take the long way around, through a circuit. And that flow of electrons, that is your electricity. Finally, in step 4, those electrons, the protons, and some oxygen all meet up on the other side, the cathode, to form the only thing left over, water.
All right, let's look at that anode side again. In our little analogy here, you see stuff breaking down on the left? Well, in our hydrogen fuel cell, that's kind of what's happening. The hydrogen gas comes in, and a catalyst basically rips its electrons away. And those newly freed electrons, they're the whole point. They get forced to travel through a wire, and that's what powers whatever you've hooked up to the fuel cell.
And now for the other side, the cathode. In our analogy picture, you see new material being built up. For our fuel cell, this is like the grand finale, the reunion party. It's where everything comes back together. The electrons that just did all the work, the leftover hydrogen protons that came through the middle, and oxygen that's just pulled from the air. They all combine, and what do you get? The one and only byproduct, pure water, H2O.
So why is this whole process such a big deal? Well, it all comes down to one word: efficiency. Think about a regular car engine. It's basically a series of controlled explosions, right? And it gets incredibly hot. That heat is wasted energy, tons of it actually. Because a fuel cell doesn't burn anything, it skips all that waste. It's just so much better at turning fuel directly into useful electricity.
Okay, but let's talk about the elephant in the room. You're probably thinking, wait a minute, isn't hydrogen, super explosive? And yep, you are absolutely right. But here's the really clever part of the fuel cell's design. The hydrogen and the oxygen are never allowed to mix directly. They're kept on separate sides of that barrier, that electrolyte. This prevents the big boom and instead gives you a safe, controlled release of energy.
This all sounds pretty fantastic, doesn't it? But it leads to a really obvious and really important question. If hydrogen is the fuel, where on earth do we get it?
Well, right now, there are basically two main sources. The most common way, believe it or not, is from natural gas. You react it with steam to get hydrogen. And, that works, but you're still using a fossil fuel, which kind of defeats the purpose. The real dream, the clean vision for the future, is the second method, electrolysis. This is where you use electricity, and ideally electricity from something like solar or wind, to split water molecules into pure hydrogen and oxygen. This is what people call green hydrogen, and it's the holy grail for a totally clean energy cycle.
So now let's zoom back out and look at the big picture. We need to talk about what you might call the hydrogen dilemma. It's this constant balancing act between the amazing promise of this clean tech and some very real-world challenges.
So on the promise side of the scale, the list is awesome. You get zero air pollution. It can be a totally renewable fuel source. You can make electricity 24/7 as long as you have fuel, and it's super efficient. But on the peril side, the challenges are just as big. Making hydrogen, especially the green kind, is really expensive right now. Storing it is tough. You need heavy, costly tanks. And yeah, we have to remember it's still highly flammable, and you have to be really careful with it.
So after all that, where do we stand? That brings us to our final and maybe most important question. What's the future for hydrogen? Is this really going to be a key to powering our world tomorrow?
Look, here's the bottom line. Hydrogen fuel cells absolutely offer a potential path to a truly sustainable future. The science is solid, it works, it's clean, it's efficient, and it runs on the most common thing in the universe. The big if, it isn't about the science anymore. It's about engineering and economics. Our hydrogen-powered future really depends on whether we can innovate our way past those big hurdles of cost and safety.
And that really leaves us with the big question to think about. We actually have the technology. It is literally rocket science that we've figured out how to use right here on Earth. So the real question now is for us. Can we overcome the costs and the risks to finally unlock hydrogen's incredible promise for a cleaner planet?